Okay, this next one that I'm going to do is from homework 7.1, problem number 1. Given the random sample results below, conduct a difference between means test and describe what the results mean. Okay? And basically, ideally, we've done this in the past. All we're doing here, the reason we're doing the t-test is because before we were just looking at one sample, but now we have the population and we've sampled 2 different groups in the population. Let's say we've sampled men, I'm just making this up, and women. All right? And let's say that I know on average, the men that we sampled, on average, their salaries are $34,000 and the women's salaries on average are $27,500. The men have a standard deviation of 1575 and there were a total of 40 men sampled. With the women, they have a standard deviation of 2,000 and there were a total of 36 women sampled. Okay, so this is the money. Well, let me not even say money. This is the X bar for each group. Here's the standard deviation for each group. And here is the N for each group. All right. To do a differences between means test, you sort of have to have a hypothesis. And what my hypothesis is that the population, because that's what I'm concerned about, right? The M1 equals M2. So then on average, mu, which is the population mean, on average, men's salaries equal women's salaries. And though just on the surface right here, it looks like there's a problem, right? There's a difference here. And it looks like men on average make more than women. But I don't know if it's just that the 40 people that I sampled, the guys, they just happen to, randomly have been selected, but happen to be the people who made higher wages. Or it could be perhaps because the women that I sampled 36 of them. Let's say I just randomly sampled 36 and those happen to be the 36 out of 1.2 million women who happen to make, the least amount of money. So what you want to do is you want to set up your null hypothesis and your alternative, right? And you can just simply say that they do not equal each other. All right. There are several ways to calculate the standard error of the difference between the means. The book has one way. If you look it up on different videos, there'll be others. I used the book methodology simply because you had a copy of that. However, as I pointed out before, I'm not too worried about if you get the exact same number because you can kind of come back into it a roundabout way. So if you use the formula from the book, and I'm so used to doing the calculators, but really, I wanted you all to be able to calculate these manually at some point so that you can kind of start to jive to, okay, what am I not just grab numbers and throwing them in a pot, right? You're going to take N of example.
Alright. Make sure you don't lose your square root bracket. Or if you do, make sure that you just put it back later. So if we do all the math, everything comes out. The number that I ended up with was 416.49. And just as a refresher, guys, in the appendix 1, there's information there about hierarchy. You want to square this 1575 first and multiply it by 40. You don't want to add the 40 or multiply this and then square it. You want to square the 1575 first and then multiply by 40. Same thing, you want to get that whole term down before you do this. So I end up here with the standard error of the difference between means for 416.49. All right, in order to calculate your t ratio, because remember this is just, in doing these tests, you're going to have a critical value, a t value, and you're going to have an obtained t. All right, this obtained, you want to compare your critical value t to your obtained t. This is how you calculate the obtained t. All right, you take the difference between the two, and order is important here. You always want to subtract the second from the first. So I have 34,000 minus the 27.5 divided by what I ended up with a standard error, right? And I equal with, that comes for me for 15.60. Hold on, let me look back at my numbers again because I'm trying to got my phone up. All right. Next, you want to calculate your degrees of freedom to get the critical value. So this is my obtained T. I want to get the critical value, right? For the critical value, I always want to use like an alpha equal to 0.05 if it's not stated. You could either use alpha 0.05 or you could use alpha 0.01. You know, for here we might reject the null. Here we may, you know, not reject the null. Just depends. And for your degrees of freedom, let's see. Because I've got the two scores here, you're going to take N1 plus N2 minus 2. So I'm going to have 40 plus, I'm trying to let this come into focus before I go further. Sorry, guys, if it seems like I'm kind of slow. All right, 74. All right, so my critical value using degrees of freedom 74, and this kind of talked about this in the sample video that I did. You want to go back to your table again. And we are using here table C, critical values. And our degrees of freedom is 74. But if you go down here, you notice that there isn't a 74. So you need to, just to err on the side of caution, you want to go down from the 74 to the 60. And we're using the level of significance. Let me hold this up. All right, come across here. Just depending on the 1.67 or the 2, okay? Depending on what level of significance. Here, 0.10 alpha. Here's a 0.05 alpha. I like to use the 0.05 alpha, so I'm going to use the 2. Let me go back in here. Let me go ahead and pull my calculator out. Oh, hold 1 second. Three, 4, 1, 2, 3, minus. All right. Going to draw out your normal distribution curve here. And you want to mark off our critical values, right? And I was going to go with the 2.0. My critical value is 2.0 because I'm using an alpha of 0.05. All right, so that's a negative 2.0 and a positive 2.0. So what I want to know is, on average, do men and women make the same amount of money? All right, if my obtained t-score falls within this region, this tail, or this tail, I'm going to have to reject my null hypothesis that men basically equal, that men's average, that in the population, that men's salaries average are usually equal to women's salaries on average. All right, I got my 2.0. I go back in here. And I see that 0.60 is way, way out there, right? So I end up, think about this, with a score all the way out here, right? This is clearly in my reject region, right? In my reject area. So I have to reject the null hypothesis, right? I'm going to have to reject the null hypothesis, okay? This is when I'm using a 95% with an alpha of 0.05. Here I would reject the null. And so basically all that's saying is that there is a relationship between what you make and your gender.
So this would be fair for someone to say that men get paid on average more than women. Because I felt I have to reject my null, which was equal to the population mean for men and women. And I have to accept the fact that men and women do not make the same. Now I could change this up if I wanted to be more stringent. I could go to an alpha of 0.0005 or 0.01. All these different, but even still, because my obtained value critical, my obtained t was so high, I would probably end up rejecting the null with any sort of alpha.